Okay, so welcome to this course on add-on development in Blender. By the end of this course, you're going to have built yourself a nice little structural analysis add-on right inside of Blender. Now, I've been using Blender for years at this point, over 10 years at this point, and I've always thought to myself it would be really good to be able to do structural analysis directly inside of Blender. And so that's exactly what we're going to achieve in this course. Now, the add-on itself, the structural analysis add-on that we're going to build, StructureWorks, that's not really the point of the course. The real aim of this course is to get you to a point where you're comfortable building your own add-ons in Blender. That's the real win from this course and the real takeaway. Now, your add-ons can be simple little tools that maybe shave 30 seconds off an operation that you do maybe a few times a week, maybe a few times a day. They can be that all the way up to really feature-rich pieces of additional functionality that you bolt onto Blender. There really is a wide spectrum. Pretty much anything that you want to do or speed up or automate inside of Blender, there's a good chance that you can build an add-on to help you do that. Now, you can build add-ons for your own personal use, or you can distribute them either for free or as paid assets. Blender is a huge platform with a rapidly growing user base. The number of industries that are now finding Blender to be a useful tool within their workflows is growing all the time. So being proficient as a developer for this space can open doors for you, and depending on how seriously you take it, add-on development really is just software development for a specific platform. In this case, that platform is Blender. So use this course as your jumpstart into mastering this new skill set. There really is no telling how far it will take you or where it will take you, again, depending on how seriously you pursue it after completing this course. So there's a good chance that if you're here watching this video and you've decided to take this course, you've probably seen one of my demo videos online where I've sort of worked through the analysis of a structure using the StructureWorks add-on. But on the off chance that you find yourself here and you haven't seen this add-on yet, or you haven't seen me use it, I'm going to run through a very simple, quick analysis here that just demonstrates the basic functionality of the add-on. So here I am over here in Blender, and I've got the add-on shown here on the right-hand side. It's coming in from the N panel, so if I hit N, it goes away, hit N, it comes back. And what we've got here is a very simple triangular truss. If your version of Blender looks a little bit different to this, don't worry, we'll be talking about setting up Blender in an upcoming video. So essentially, imagine you've got some structure and you want to analyze it. The first thing you have to do is build a mesh representation of that structure, okay? And Blender makes that really easy to do. We won't go over much structural modeling, to be honest. We might do a little bit of it, but basically the assumption is that you're starting off with some kind of mesh representation that consists of vertices and edges, and that's your structure basically. So the first thing that we would do if we wanted to do a structural analysis of this structure is we would expand our first panel here, our structure mesh panel, and we would select it. Now you can see I've already selected it here. I'm going to X out of that, and I'm going to select it again, right? So if I want to select the structure, I just hit the little eyedropper here, come on over and click on it, and then that basically tells the add-on that that's the structure that we want to analyze. Now we can show a mesh representation of that structure by just hitting member mesh, and if I turn off the wireframe underneath, we can see a mesh representation of the structure. That just generates a series of faces which make the structure a little bit easier to see. So we'll hide that for now, bring our mesh back, and come on down to materials. So in our add-on, we'll be able to specify different materials and their properties. I already have one pre-populated here for steel. So I want to assign steel to all of the elements within my add-on. I'm going to tab into edit mode here. I'm going to select everything and I'm going to hit assign. And that will assign steel to all of the members in our structure. So if I then hit material numbers, we can see that material 1 has been assigned to all of the elements in our structure. All right then, so we can collapse that down. We'll come on down to sections. Now again, we can specify any number of different sections with associated cross-section properties that we like. I've got 2 pre-populated here and 2 tubular sections. This is a truss analysis. Essentially, each member in this structure is actually loaded, and so all we really care about is the cross-sectional area for the purposes of this analysis. But you can see there's some additional cross-section properties. We'll leave them at 0, but when I go to expand this, and indeed when you go to expand your version of this add-on, you may well expand into bending analysis where these properties will become relevant for you. But for now, we're really just interested in the cross-sectional area. So what I could do is I could go ahead and assign different cross-sections to different elements within our structure. I'll switch over to edge select mode. You could do that. Now what I'll do is I will just, for simplicity's sake, I'll just assign everything to be a 75mm tube. So again, with everything selected here, I can just hit assign, and then we can come on over and see our section numbers, turn those on, and we can see everything is section 2. But obviously we could assign different sections to different elements depending on what we want to do. Alright then, so we'll collapse that guy down. Next up is restraints. So we apply restraints to vertices. So I'm going to switch back into vertex select. I'm going to deselect everything. Now I want this node here to be a full pin, right? So I'm going to come into restraints. I want that restrained in the X, the Y, and the Z direction. So I can hit add selected, and that will add restraints to that node there. And of course I can increase the scale so I can see them a little bit more easily. Okay, there we go. So next up, I want to restrain this node in the Z, the vertical direction, and in the X direction. Yes, the Z and the X direction. So I'm going to unselect Y restraint. So we've got Z and X selected, and then I will assign that set of restraints to the currently selected node by hitting add selected. And there we have it. And in fact, I can add the same restraints to this node down here and this node here. And I'll just hit add selected. And now our model is sufficiently restrained. Now, the add-on assumes you know what you're doing, right? So if you try and model a structure and you don't provide sufficient restraint, for example, if your structure is not sufficiently restrained such that the structure exhibits free body rotation or becomes a mechanism, it's not sufficiently triangulated, your analysis won't work. And the add-on assumes that you have put a structure in here that is stable. So now that we have our restraints specified, let's come on down to our applied loads. Now we could toggle on self-weight or not. I'll leave it off for now. But what I want to do here is I want to come into front view mode. So I hit 1 on the, no, it's going to be 3 for this particular structure. I'm going to deselect the nodes I currently had selected, and I'm going to select these guys here. Now I'm going to turn on my X-ray selection so I can select through things. So I'll come on back here and then select that again, and that'll select all of those nodes. Now I want to apply some point loads there. Let's go with minus 10 kilonewtons. That's going to be minus 10 E3, so that's 10,000. The other thing to say is the add-on also doesn't make any assumptions about what units you're using. It will assume that you are dimensionally consistent in your units. And so what I would suggest or recommend is that you pick a set of units and be consistent all the way through your use when you're inputting information into the add-on. So in my case here, I'm sticking with meters and newtons, which is fairly typical. And that's why we've got minus 10,000 here for 10 kilonewtons in the Z direction. Z is positive upwards, and so our force is going down, so it's going to be minus 10,000. So with that selected, those nodes selected, I can hit add selected. And then we see we have some forces applied to our structure. So that's the bare minimum we need to do, right? We've defined a structure, we've assigned materials and sections, we have restrained our model, we've applied forces to it. Next, I can come on down to, well, I could export this problem definition, and that would allow me to analyze it externally, which we will do at the end of the course. I won't do that for now. Let's just hit analyze now, right? So to analyze the structure, we want to be in what's called object mode rather than edit mode. So I can tab and I go into object mode, and then I can analyze the structure. And that's it done. We see the bar comes across here, fills up with blue. That means we have some results. I can expand my results now. And now I have all of my nodal displacements, my member forces, and my reaction forces. Now, these numbers here refer to node numbers here and element numbers here. If I want to see what those node and element numbers are, I can bring up my pie menu and turn on node numbers, and I can see which node numbers, what the node numbers on the structure are, and I can relate those back to the node numbers here. And I can do the same thing. I can turn those off and I can turn on my element numbers, and again I can relate the element numbers here back to my list over here on the right hand side. That's our tables of results, but we can also visualize the results in the 3D viewport. Let's turn off element numbers and let's start off by looking at our deflected shape. So if I just turn on deflected shape, we can change the scale of our deflected shape here, but we can see what the structure wants to do, and we can go in and inspect the magnitudes of those nodal displacements quite easily as well. We can turn on labels, so we could come in and we could say let's look at the nodal displacements, and we could zoom in and we could get the displacement of any of the nodes. Okay, that's fine. So we can turn off deflected shape, turn off those labels, and now let's look at a heat map of axial forces. So again, there's member force labels, but we can also visualize a heat map of forces. So if I turn visualize forces on, on and I turn off my wireframe, so come in there, turn that off, and we can see a distribution of axial forces here in the form of a heat map. We can change the heat map we're looking at. That's a red-blue continuous, red being compression, blue being tension. It makes a lot of sense for a tension compression structure. Slightly less intuitive, but probably looks a little bit nicer, is a jet color map, which is this guy here. And so again, you can sort of at a glance see where the peaks are in terms of compression and tension in your structure, and then you can turn on your labels and see the actual forces on there. So we can go with member forces, and we can zoom in and see what the member forces are at different points in our structure. All right then, I think you get the idea. That's the basic idea. So let me turn that off, bring my mesh structure back, and that's the basis or the basics of what we're going to build. We'll build all of this functionality. We'll build the functionality to export our results. We have an additional menu down here, which is just all of our UI controls collected into one panel. And we'll also build this really handy, which is what I use almost all the time, this handy little pie menu, which we can customize, obviously, because we're building it. But you can put in whatever options you want in here. And I've chosen to add all of the options that are controlling visibility of things in the viewport. It's really, really handy to have them all collected here. So, as I said, that is what we're going to build. If you're a structural engineer, you look at this, you probably think that's pretty cool. That could have been what brought you to the course. That's fine. If you're taking this course, which is really, really possible, and you're not an engineer, you might look at this and go, yeah, okay, I suppose that's cool, but really, I just want to know how to build add-ons, and that's absolutely fine. I'm going to talk a little bit more about how all different kinds of user can get the most out of this course in an upcoming video shortly. But for now, I'm going to leave the demo there and just talk very briefly here about what is the order of operations here. We're going to build this add-on. Let me collapse everything down here and make it a little bit easier to look at. We're going to build this add-on in a fairly sequential fashion. Okay, so I'm going to try and move and build panel by panel as we move on down, pretty much in the order that we've used them. That's going to be the easiest way, I think, for you to follow along. I'll try and minimize as much as possible the amount of jumping back and forth. Sort of, we'll try and finish a panel and then move on and finish the next one, and so on and so forth. But that's not going to be possible all of the time. We'll have to jump back every now and then just to update options and panels and what have you. So there'll be a little bit of jumping around, but I'll try and minimize it as much as possible. Now, the last thing that I want to talk very briefly about here is Python. At the start of any engineering skills course that involves Python, the question usually arises, do I need to know Python to complete this course? Now, I always say actually, no, it's not essential to know Python, but it is a help, right? The same is true in this course. You can get through this course and you can, successfully get through it and be very confident in building add-ons by the time you get to the end if you're coming in not knowing Python. That's absolutely possible. The course it's going to take you a little bit longer to complete. It's going to be a little bit more challenging, but it is absolutely doable. So I wouldn't want anyone to be discouraged from taking the course just because they don't know Python or haven't programmed before. So that's the first thing to say. Python, like any programming language, is just about setting up a list of instructions for the computer to execute. And to be honest with you, once you've seen that done X number of times, it starts to become pretty obvious what's happening. You can start to realize, the syntax that's used, the different conventions that are used in different languages, and Python is a very straightforward one to use. So you can pretty much pick it up more or less as you're working through the course. But I don't want to understate it either. It is going to be more challenging for you, so just be prepared for that. You're going to have a little bit more perseverance as you're working through the course, and it'll just take you that bit longer. Now, if you haven't used Python but you've programmed before, well, you're going to be fine. I mean, if you're comfortable programming, you kind of know the score now that any programming language is really, once you know one, you can pick up another one pretty quickly, and get to a relatively comfortable level in terms of using that new language pretty quickly. So don't even think twice about it if you've programmed in another language. If you have Python, that's just going to make it that little bit easier and that little bit quicker for you. So that's really what I have to say in terms of prerequisites on Python. You don't have to have it, but it obviously helps. The other way, you can kind of flip that on its head though, and you can kind of think about it a different way. The best way to learn a programming language, Python in this case, is by doing something useful, right? It's by picking a project and then trying to work on it and build it. And this is a great example of that. So if you don't know Python, don't look on it as, oh man, this course is going to be really hard to do. Will I, won't I? flip that on its head and say to yourself, this course is going to be my opportunity, my chance to learn Python. Because there are two ways you can learn Python, right? You can either take vanilla Python programming courses or lessons, and that is incredibly boring and gets very boring very quickly. Or you can build something that you're interested in, all right? And that's what I advocate for all the time. So this can be your vehicle, not just to learning how to build add-ons, but your vehicle to learning how to use Python as well. That's how I would view it if I was coming to this course not having Python. Now, all of that said, if you do want to take the course and you still think I might benefit from a little bit of Python help ahead of time, well, head over to the Engineering Skills website. In fact, I'll bring it up on screen now. Okay, so here we are over on Engineering Skills. If you head over to projects, there are 5 different projects here which are completely free. You can go ahead and just register an account, a free account on Engineering Skills, and you can start working on these projects, any one of them. And what these are little mini Python projects that will help you just get a little bit familiar with Python before you dive into the course. You don't have to do it, but some folks like to have that sense of familiarity with one thing before they start something else new, which is this add-on development that we'll be doing. So I'd say head over here and pick any one of these projects. They're just simple, basic engineering theory with a little bit of Python layered on top, and it just allows you to build up that little bit of a reflex, that little bit of comfort when it comes to using Python. I think that's the best way to do it, is learn by building something interesting. So if you're an engineer, you look at this and you go, shear force and bending moment diagrams, I know what they are, I'm comfortable with those. So if you then layer on a little bit of Python on top, you're learning Python in a kind of a familiar context, and that's really, really powerful. So pick any one there. We've got beam deflection, Moore circle, Duhamel integral, a project there on building apps with Victor. That's probably not one to start with. If it is Python you're trying to get familiar with, I'd stick with one of these guys, this one, or this one. But anyway, they're there for you, completely free. Head over and complete one of those, and then you can pick up basically here in this course and get cracking on add-on development. All right, so I think that's pretty much all I want to say for this sort of course introduction. In the next video, what I want to do is sort of pull the curtain back a little bit and show you behind the scenes. You've seen the front end of the add-on now and what the user actually interacts with and experiences. But in the next lecture, I want to sort of go behind the scenes and show you what's driving everything, how's it all coming together, and how are we building it basically. So we'll take a look at that, a high level look. We won't go into the detail, but a fairly high level look in the next lecture. So I'll see you in the next one.